All right, so today we are working with a rhombus. We have 5 main theorems about our rhombus. A lot of these are probably pretty familiar because we used them with rectangles and parallelograms last week. So it's going to sound pretty repetitive, but we can still apply those same theorems. So we start off knowing that all sides are congruent. So this piece is the same as this, which is the same as this, and the same as that. They are all the same size. That is what congruent means. It has the same measure. We remember the diagonals connect one vertex to another. Sorry about that. I didn't draw this in pencil first. My bad. We know that diagonals are perpendicular, which means they intersect at a right angle. So all 4 of those angles in the middle are 90 degrees. We also know that diagonals bisect each other. So this side over here is congruent to this side over here. This piece here is congruent to this piece here. Wherever they intersect splits it in half. Okay, we also know that the diagonals bisect each vertex, which means right here, Z and this other angle, those two are going to be the same measure. These two are the same measure. Here and here are the same measure, and here are also the same measure. They bisect each vertex as well. We also know that opposite angles are congruent. So angle M is congruent, again, same measure, as angle O. We know angle F is the same measure as angle R. And lastly, we have adjacent angles are supplementary. So angle F and angle M add up to 180 degrees. M and R add up to 180, R and O are 180, O and F. Okay, supplementary angles are going to be your adjacent angles with a rhombus. So we have a problem here. The directions that I forgot to write down tell us to solve for all of the missing variables. So we have W, X, Y, and Z. Okay, the easiest thing to start off with is W. Okay, we know that diagonals bisect each vertex, which means these two angles are going to be the same. If this one side of the angle is 54, we know that W is also 54. Easy peasy. The next thing, we can just go in order and solve for X. We're working with the diagonal. We know that they bisect each other, which means we can set these two pieces equal to each other. We have 3x plus 2 is equal to 6x minus 7. We want to get our constants on one side and our variables on the other. So just to keep positive numbers, I'm going to take 3x from the left to the right. I'm going to add 7 from the right to the left. We have 9 is equal to 3x. Then we're going to divide both sides by 3. 3 is equal to x. All right, 2 variables down, 2 to go. Now we have y. Y is talking about the sides. We have this top part is 2y plus 4. The bottom part is just 4y. We know that they are congruent, so similar to how we did this, we're going to set them equal to each other. 4y is equal to 2y plus 4. We're going to subtract 2y from both sides. We have 4y. Whoops, that should be a 2y, my bad. 4y minus 2y gives us 2y. It's equal to 4. Divide both sides by 2. Y is equal to 2. And then lastly, we have z, which is looking at this angle right up here. We know that this is creating a triangle, and we should remember, hopefully we do, that a triangle adds up to 180 degrees. So if we know that this angle is 90, this one's 54, we can subtract that from 180 to get z. So we're going to do this vertically. We know that 180 minus 90 minus 54 is equal to z. I said vertically, but it's horizontal. That's okay. Z is equal to 36. So we're going to go up here, write that. We have W, X, Y, and Z. Using all of these theorems, we can solve these problems just by setting it equal to each other, adding it up, setting it equal to 180 if we're talking about the angles. Pretty straightforward. I'm going to zoom in so you can see the example, maybe get a better picture of it. Again, sorry for that. Hopefully you guys get this.